X-ray now continues on its way into position under the press. The operator touches a switch, the press starts down, and look out below. Almost unbelievable pressure, an irresistible force, but under perfect control. And where plain sheet metal went in, finished parts come out. The hydro press turns out more parts in 1 minute than 2 men could complete in a whole day, and turns them out better and more accurately. A compressed air stamp which forges metal is an excellent example of powerful machinery under absolute control. Taps as gentle as a tack hammer, then the crushing impact. What a nutcracker this outfit would make. And yet its control is so delicate that it can crack an egg, at least so the operator claims. Look out there, a little too hard and you'll have an awful mess. Be careful. Well, hello, stranger. You certainly have a brand new kind of a mama. Skilled men and precision machines have fabricated these parts. But even metal can be strengthened and protected. To do this, there are several types of processing. Complete electrochemical anodizing baths provide parts with a protective coating of oxide film. This is a safeguard against the threat of corrosion caused by moisture. It is an interesting fact that these parts are protected against any harmful effects of moisture by being given a bath. Another type of bath is used for a different purpose. In order to harden and thereby strengthen certain parts, they are immersed in a hot salt solution of sodium potassium nitrate. In large ovens, other parts are hardened by baking at 1550 degrees Fahrenheit and quenching them in oil. It is easy enough to say that these parts, which will eventually be the plane, are strong. To prove that they are, to constantly guard the Lockheed measure of strength is the duty of the testing laboratory. A spectrograph is one of the most modern scientific testing devices. It analyzes the purity of the metal alloys which go into a plane. Tremendous heat created by an arc burns sample filings of the metal. These filings are placed in a cavity on the lower of 2 acid-treated graphite electrodes and then burned. The light of the burning metal passes through a lens and then through a rotating sector, the adjustable opening of which controls the amount of light falling on the slit. The light now passes through the slit and falls upon a diffraction grating. This diffraction grating is a concave aluminumized glass plate on which 24,000 lines per inch have been ruled with a diamond point. The light is separated by the grating into wavelengths. These wavelengths, or light rays, fall upon a strip of film, and a photographic record of them is thus produced. Since each element has its own wavelength, from the developed film it is possible to determine exactly which are present in the alloy. In this manner, the spectrograph immediately detects all impurities, and any inferior metal is promptly discarded. The sole purpose of this huge machine is to break things. Its powerful jaws, capable of a compression of 300,000 pounds, are about to crush a small section of the wing in order to measure its resistance. Now watch carefully. The upper jaw is clamping down with an invisible, relentless force on the seemingly frail strip of metal. But actually, just how frail is it? 60,000 pounds? 70,000? There it is, a slight ripple. The breaking point has been reached, and it takes a pressure of over 80,000 pounds to even bend this frail little section of a wing. For contrast, let's see what happens to a solid cylinder of concrete, which certainly appears much stronger. There is the first crack, and the concrete shatters completely under a pressure of less than 75,000 pounds. All stressed parts, such as forgings and castings, are X-rayed for any possible flaws in the metal. Lockheed X-rays more parts than all other aircraft manufacturers combined. They may look new and shiny on the surface, but that doesn't matter. What are they like underneath? This batch is fine, perfect. A different story here. Those slight, almost imperceptible flaws which doom it to the scrap heap would be invisible to any eye other than the X-ray. Therefore, although it is important to know what is on the outside of a plane, every stressed part is X-rayed because Lockheed thinks it is even more important to be absolutely positive of what is on the inside. Yes, every part of this plane is built for the strength, ruggedness, and durability to achieve the highest speeds. And there goes the Loadstar. Carrying a full load of 17,500 pounds, it speeds down the runway for the takeoff. In 15 seconds, after a run of only 860 feet, it leaves the ground and soars into the air. Climbing rate 1,200 feet per minute. And while the plane is in flight, the dials and indicators on the panel are the guides by which a pilot flies. Over a half a mile of wire connects them with the controlling instruments, which must be infinitely accurate before they are installed. In the instrument testing laboratory, each instrument and accessory is, to all intents and purposes, actually flown before being installed on the plane itself. For instance, on this stand, a motor duplicates the swing of a plane to test the turn and bank indicators. Here, tachometers are also tested, and propeller governors, vacuum pumps, fuel pumps, starters, generators, and hydromatic motors for feathering propellers. The automatic pilot is checked by a vacuum system against mercury manometers. This small box can guide a plane in flight, keep it as true to its course as the most experienced pilot. An airplane is a chain of which the thousands of separate parts are the links. They must be forged together in order to shape the wing, the tail, and the fuselage. The duty of the wing is to provide the lift that sustains the flight of an airplane. Here in the plant, it must be assembled as flawlessly as it was designed. Although a wing is generally considered as a unit, it is really composed of 3 parts, 2 outer sections and the center section. We are all familiar with the general shape of a wing, but while an outer section is in the first stages of assembly, we can get a good idea of the complex structure on the inside. Every rib and crosspiece has its purpose.